Hi, in this video we will learn what is the substitution rule for indefinite integrals. Well, let me start with one integral or antiderivative, sine of x plus 2 dx. Well, you look at this integral and you say that, okay, I know what is antiderivative of sine x dx. This is just minus cosine x plus any constant you add. But here, I don't have a sine of just x. It's x plus 2. Well, if you think a little bit more, you notice that there is only one way in the differentiation such that you get a function combined to another function, and that is when we have the so-called chain rule. Chain rule is for the derivative of composition of two functions. And what it gives us, it just tells this is derivative of outer one times derivative of inner one. Okay, by the definition of an antiderivative, so you see differentiation is this way, antiderivative is this way. And well, by that definition now you see that integral of h prime of gx, g prime of x dx is going to be h of gx plus c. And this is only way that we can see a function in the integrand is composed with another function. But the pattern here is what substitution asks you to identify. When you have an integrand which has these two parts, f composed with a function, then multiplied by the derivative of the same function. Okay. In this case, well, let's call this guy x integral. Substitution rule says that if you have an integral of this form, you can turn it into another integral. Well, I will call it u integral. What we do is that we introduce a new variable u and we substitute gx by u. Well, in that case, then the first part of the integral is going to be f at u. Then you say that, okay, there is this dx. My u integral is supposed to have only the variable u, no x's. Okay, how can I turn dx to du? Well, this is a very key point of the substitution. Substitution says don't replace dx by du. What you need to see is that substitution that you choose, u equal to gx, will give a relation between dx and du. So du can be written in terms of dx. How is it this relation, how is it found, is here. If u is equal to gx, du is going to be equal to g prime of x du. So the way you write du is you have to find derivative of g multiplied to dx and take that whole thing and put du in your u integral. Very nice. You may say that, okay, how this is going to help us? We had an integral. We now turned a new integral, turn it to a new integral. The substitution says, substitution rule says that these two integrals are equal. Okay, if I want to write the details of the substitution rule, I need to have a differentiable function. And f be a continuous function. Then integral of f gx times g prime of x dx is equal to integral of f u du, this du. In other words, the x integral, if you follow the instruction I just gave you, will be equal to this new integral u integral. Okay, so this way, for example, if you have that sine of x plus 2 that we started with, you see there is this inside sine is this function, so I will take that as my u is equal to x plus 2. Then I have to find what is the relation between du and dx. The relation is given by du is going to be derivative of that function that u is equal to times dx. In other words, this is du is equal to dx. In this example, du and dx are the same thing. In other words, my x integral will turn to very simple u integral, sine of u du, which I know this is asking for antiderivative of sine u. Well, it will be minus cosine u, same variable. And, well, I turned x integral to u integral. I found the u integral, the value of the u integral. Now, someone gives you this integral and leaves the room, and you try to solve it and get to this point. The person comes back and says, what is the answer? You say minus cosine u plus c. Well, the person can ask you, what is that u? The function I gave you were in terms of variable x. You're now giving me a function in terms of u? What on earth? Where on earth this come from with this u variable? Well, you say you're right. U is a variable I introduced. So now I have to get rid of it. How? I know what to do there. Wherever you see u, you plug in back x plus 2, and that will be your answer now. And that person will be happy and will live happily ever. Well, this part, these steps, you find the right g and then replace the u with right part of a function. This is called substitution, and you need to learn how to do it through different examples. Let me just bring in some of these examples. Here I have given you what is the substitution, the right substitution to be applied, and you need to turn this x integral into u integral. Here, I know that this part is u, so I have a square root of u. But what about du? Well, du and dx are related by du is going to be the derivative of 1 plus x cubed, which is 3x squared times dx. And here you notice that, okay, look at this guy, 3x squared times dx is here. So for that part, I will put du. And here inside the integral, I have root of u. So I turned x integral to u integral. Now, u integral is supposed to be easy integral to handle. Here, as you see, this is just a simple power rule. In integration, we have half plus 1 u to the power half plus 1 plus c, which is equal to 2/3 of square root of u to the power 3 plus c. Remember, we are not done until you put back x into your final answer. So wherever you see u, you plug in 1 plus x cubed. Well, this is u to the power 3. This will be 1 plus x cubed to the power 3 square root. How about this one? Okay, here I want to write u integral. U is a tan x. Then there will be a relation between du and dx. What is the relation? Du is going to be equal to derivative of tan x, which is secant squared x, times dx. You look at your integral. Oh, okay. You see there the integrand has a factor of secant squared times dx. I can replace it by du. And this is e to the power tan x. What tan x is just u. X integral into u integral. The integration is not done. The substitution is done. Now I can integrate this guy. I know what is antiderivative of e to the power u. It is just e to the power u plus c. But I'm not done. The integration is not complete until I put back in the original variable. So instead of u, you put tan x back into your final answer. So that is the answer we have there. And this last example, 3x minus 1, very nice. I have u to the power 10 here. And what is the relation between du and dx? Well, derivative of 3x minus 1 is just 3. And then you look at this integral, you say, oh, I don't have any 3 there. What should I do? Well, it's easy in this case because that 3 is constant. You can multiply a 3 here and then divide the whole integral by 3. Constant multiple rule says that those two cancel each other and you have the original integral. This way you have 3 dx. I can replace it by du, but we have a guest here. We have to take that 1 over 3 given by that part. And this you can do anytime you have a multiple of the whole derivative times dx. So you can produce that multiple just by multiplying and dividing. So here 1 over 3, then 1 over, this is power rule again, and then plus c. We are not done. Okay, so let me just put this one, 1 over 33 u to the power 11 plus c. And this is not done until I put back x in. Instead of u, you plug in 3x minus 1 to the power 11. In the denominator, we have 33 plus c. So this is substitution and how it works. You definitely need to work through more examples and do more substitution. Detecting what is the right function to set u to be equal, that's one step. The second step is how to transfer your x integral to u integral and then find that integral and get back onto x variable. These are the things that we will do through some more examples.